Hi everybody, this is lesson 2, justifying equations, and I'm doing something a little bit different. I'm not going to be in the video, but I am going to be talking to you and still be able to write on it. So hopefully I'm not in the way and making the um, camera out of focus, but you should be able to still be able to hear my voice and see what I'm writing. I'm still going to encourage you to take notes. This one is a little bit of heavy notes at the beginning, so there's a lot of writing, some vocabulary. Definitely need you watching this video. So if you're already watching the video, great. I'm very excited to do some justifying equations with you. So what we're going to do is we're going to go ahead and get into the vocabulary. So you can either return to that 2-column table that you made from lesson 1, or if there's not enough room and you need a new table, you could go ahead and draw a new table. For words I know and words I don't know, these are the new words. So we're looking at properties of equality and inverse operations. So do you know what the properties of equality are? Do you know what inverse operations are? So take this time to figure out, are these words you know or don't know? Now, if you don't know them, let's go ahead and define them. So properties of equality are algebraic truths. You actually use these all the time when you're solving an equation. You just don't really talk about their names. You may say, well, I'm adding 5 to each side or 5 to both sides. I've seen in homework 0, I saw a lot of that. I'm dividing both sides by 3. So we're just really applying an actual name to that, and they have some specific names. Um, Inverse operations, I tried to use that interchangeably with the words opposite operations, but basically operations that undo each other. And going through some of the homework 0 stuff, some people were saying, like say I had x plus 5 equals 3, and so we have addition of 5 and we want to move that, and so they were adding 5 again to both sides, and that's not going to work because the opposite of adding isn't adding. So we want to use the inverse operation or the opposite operation because they undo each other. Addition and subtraction are inverse operations. They undo each other. Multiplication and division are inverse operations. They undo each other. So when you go through and you're working an equation, you're going to want to see this is the operation, and really just say, this is the operation that I see, what is the inverse of that operation, and that's what you use. Some of you are trying to divide by fractions. We don't divide by fractions. I'm going to reiterate that. We do not divide by fractions in this class, so just keep that in mind. All right, by the end of this lesson, I would like you to at least know what it means to justify a solution, and you should be able to go back to your notes and look at the possibilities and use that to help you. Eventually, I would like you to get to where you're like just going through and as you solve the equation, you are giving the properties of equality as you go through. But you may need to go back and refer to your notes for now, and that's okay. Um, so this is one of our standards, and it says explain each step in solving an equation as following from the equality of numbers. So that's that property of equality asserted at the previous step. So sometimes the state, when they give us a question that uses the standard, they may say, okay, to go from step 1 to step 2, what was that step? So you may have to kind of go backwards and look. So that's what that previous step thing means. So you're starting from the idea that the original equation has a solution, you're building a viable argument. So basically you're saying, yes, I can solve this equation because I am allowed to add 5 to both sides of this equation, and then I'm going to divide by 3, and that allows me to find a solution to this. So it's like you're developing an argument. And so this line of thinking goes very well for people who want to be lawyers or people who want to debate and defend themselves, because everything is logical. I can do this because of this. I can do this other thing because of this other thing. And so it's very logical. So if you are in that mindset, you're probably going to be like, yeah, this makes a lot of sense. For some people, it's just like, the way that I explain it is you're just giving a reason why you're allowed to do it. So it's like, what rule allows you to do these things? Okay, so we're also going to continue to solve linear equations in one variable. So it's like we kind of just cranked it up a notch from lesson 1. We're going to still be solving equations, but then we're going to just kind of tack on the justifications along with it. All right, so here is a table, and you can make this table in your notes if you like, the exact same way, or you can do it like all where it's just one column. I leave that up to you. But in underneath each of these titles, we are going to add what the actual property of equality is saying. So if you notice, we have addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. And at this point, if you've not already written this down, you might want to pause the video and just write all this down, because as I go through, I'm going to be talking about each one, and you don't want to be writing and listening to me talk at the same time. So you can pause the video and write all these notes, and there's quite a few of these. The addition property of equality, if A equals B, so if two things are equal, then I am allowed to add, see my, there we go, I can add the same thing to both sides. And we use that a lot. If you add 2 to one side of the equal sign, you have to add 2 to the other side to keep it balanced. So I'm adding these values to the same side, or to the same values to different sides of the equation, and it's still going to be equal. All right, the subtraction property of equality says if A equals B, if two things are equal, then A minus C equals B minus C. So I'm allowed to subtract the same thing on both sides of that equal sign, and I'm still going to be able to keep it equal. So these pieces are basically what the subtraction property of equality is saying. I'm allowed to subtract the same thing on both sides, and you use that a lot in solving your equations. These are just the names. All right, if multiplication property of equality, if A equals B, then A times C equals B times C. Now notice those dots. I think I said in one of the other videos, we're going to move away from using an X to represent multiplication, and you're going to be moving closer to either putting a dot or one of the other ways. Actually, there's two other ways. We could do A and with parentheses C, B parentheses C, or you could just say AC equals BC, because when they are standing next to each other, that implies multiplication. So all of those mean the same thing, but notice that A and B are there, they're equal to each other, and there's a C on both sides. I could not say A equals BC, because that would mean that I only have a C on one side. All right. Division property of equality. Now this one, the formatting is a little bit off from what I like, but it's hard to get the computer to do everything that you like. So I really would prefer that. So A over C equals B over C. We're going to really rely on the fraction bar. So I want you to say goodbye to multiplying that way and dividing that way. I know you saw some of that in lesson 0, because that's going to be the easier way to show that we're dividing two fractions, but I didn't want to show you something that was super scary. And say hello to your times that's a dot and your fraction bar. I'm going to run out of room. Bar. Woo! Get out of there. Bar. Okay, so you're going to say bye to the X to represent multiply and that division sign, which really, that division sign when you do this and this and this, that's your fraction bar right there. Let me change colors. Here's your fraction bar right here. This represents something in the numerator. This represents something in the denominator. So really it is a fraction bar, but it's kind of got a little bit different meaning. But notice, we are dividing both sides by the same value. So that's the division property of equality. I'm allowed to divide both sides by the same value. All right, now we have other things, other properties of equality. Now, these, I'm going to go ahead and share them with you. Really, we're probably only going to really run into one of these for ourselves. The rest of them are kind of geometric properties of equality. I like to show you that there's more than just the addition, subtraction, multiplication, and division properties of equality. So just reflexive property, something equals itself. We don't see that a whole lot in algebra because x equals x or 1 equals 1. We already know that means there's infinitely many solutions. But that is used a lot in geometry. Symmetric property, if A equals B, then B equals A. We use that quite a bit. So this one, well, we use the symmetric property of equality quite a bit as far as if my final answer is 12 equals x, I kind of already know that I could rewrite it as x equals 12. So definitely like star this one. The first four are all starred. You're going to use those a lot. Symmetric property is probably going to come into play if I see something like this going to this, I would use that symmetric property of equality. The transitive property, we probably won't see it again. It's a geometry property. If A equals B and the B equals C, then A equals C. It kind of cuts out that middleman of BC or of B, gets rid of that guy and that guy. So A equals B, B equals C. Then we can just get rid of the B's and really just the first equals the last. Again, it goes back to geometry, one that we are probably not going to run into too much. Substitution property, you may use a little bit. We're probably going to use the symmetric property a little bit more. But if A and B are the same, then I can go through and anywhere there's a B, I can replace it with an A, or vice versa. Anywhere there's an A, I can replace it with a B. So substitution means I can physically remove one of those values and replace it with a different letter, or in some cases a number. Sometimes that happens where I'm plugging in a value. Oh, I don't need that. I need this to get rid of that. All right, other justifications. So these are other things that aren't necessarily properties of equality, but they are reasons that I can use in working through my equation. So one of them is the distributive property, and we talked about that in lesson 0, where we are multiplying, and some of us aren't doing this, we are multiplying the value on the outside, in this case A, everything inside that parenthesis. There could be 20 million things inside that parenthesis, and I would have to multiply each and every one of them by A. Some of you are forgetting to multiply the first term by A, and some of you are forgetting to multiply the second term by A. So you have to multiply both pieces, and you should be getting 2 terms. There's 2 terms inside that parenthesis right now. There are 2 terms in my answer. So watch out. Distributive property can be used. Probably put a star next to it. Let's put a star next to it. That gets used a lot. And how do you know it's getting used? Well, you had parentheses, and then you kind of didn't. And you ended up multiplying times more than one thing. So the distributive property is going to go there. All right, now we're going to be a little bit repetitive in this next piece. So let me go ahead and do that and that. So simplify, combine like terms, or add. All of these kind of mean the same thing. And if we were doing this like pencil paper, and you would just turn in a sheet of paper, I would take all 3 of these equally, okay? But if I turn 2x plus 3x equals 5 into 5x equals 5, so I took the 2x plus 3x and I got a 5x. I want you to call that combine like terms. I'm okay with the other 2, but I want you to get it to where you're just putting in one thing. So I really want you to call that combined like terms. Okay? Now notice that when I changed the 2x plus 3x to 5x, I didn't add something to both sides. I just added on one side. Just the left-hand side changed. And I simplified it. I added those two things together. So that's why simplify and add are being used. But just for the sake of, all kind of coming up with the same answer, we're going to call it combined like terms. Same thing goes for the next one with subtraction. You could call it simplify, you could call it subtract, but when I take 2x minus 3x equals 5 and change it to negative x, because that's what 2 minus 3 is negative 1. So 2x minus 3x is negative x. When I do that, I want to call that combining like terms. That left-hand side is condensing. I am combining like terms. Yes, I'm subtracting, but I want you to call it combined like terms. Okay? So I'm going to know if you watch the video when you go to put stuff in on Canvas. So make sure that you are keeping that straight. Now, for the next two, when we are either multiplying or dividing, I want you to use simplify. Okay? So just use simplify. I know it'd just be easier if we said simplify all the way through, but really when you're adding and subtracting, you are combining like terms. When you do multiplication, you're not combining like terms. When you do division, not combining like terms. So when I look here and I've changed this minus 3 times 4 to a minus 12, I've just multiplied, but I want you to get into your head and I want you to write down in your notes that you are going to use the word simplify. And that's just so I want you to have a common vocabulary with me. I want you to know that I'm going to keep using these words, combining like terms, and simplify for these specific operations. And I want to make sure that when it comes to be homework time or test or quiz time or anything like that, that you are going to get these problems right. Okay, so same thing that happens here, that negative 12 divided by 4 changes to a negative 3. We didn't do something to both sides. None of these examples did we add or subtract or multiply or divide anything to both sides. It was just we were combining like terms. We were getting it on one side and getting it written as simply as possible. Okay, so not everything that you add would you call an addition property of equality, only if you add something to both sides. So that property of equality, you might want to write this down. The property of equality will change something on both sides of the equal sign. Okay? So how are you going to know when to write property of equality or when to use property of equality? How are you going to know the difference between a property of equality and is it the combined like terms or the simplify? If something changes on both sides of the equal sign, then it's a property of equality. If you've moved something across using an inverse operation across that equal sign, it's a property of equality. Now, some people, especially when they're writing things out, they're like, Ms. Davis, do I have to write property of equality over and over and over again? And I'm like, just for you. So just for you guys. No, I do it all the time. Property of equality. Some people are like, addition PO or add PO. That works. Okay, but you really, really need to know what the POE stands for. Okay, so don't just rely on that abbreviation. Know that that is a property of equality because when it comes back to a multiple choice question and it says add and it says addition property of equality and you haven't been using property of equality, you might not have it stuck in your head. So make sure you're not abbreviating too much. Just keep that in mind. All right, so here we go. Now, I would highly recommend you pause the video and write these down the way that they are on the screen. All right, so here we're going to start with blanks. And we already have the problems worked out for us. It's a little bit different than the error problems. These are worked out correctly. So we're going to justify the solution. You can come across some problems, I think I mentioned it earlier, where there is a mistake made, there is a little bit of error analysis. And so your job is to figure out what went wrong or what property should they have used instead. So just keep that, kind of in your brain that this is not the only way to do this. And we will actually, this is how I'm going to introduce it to you. We're actually going to move to where we're writing our own. So the goal is to get from point A to point D in this case and be able to fill in all these blanks. Now, if you notice, for the first one, it says given. And basically, why are you doing this problem? Well, it was given to me that way. I was given this problem to solve. So this, and for number 2, these two, those are your starting points. Those are your givens. All right, your job is to figure out how we can go from that step A to step B. So you're going to have to look at, well, what did they do? What changed? So if I notice, I have 5x here and here. I don't have that minus 6. I have the 3x. And then now instead of a plus 2, I have a plus 8. So something happened with that 6, and we moved it to the other side and changed that 2 to an 8. And so the question is, what happened? What did we do? And you don't have to do this part, but sometimes, especially at least early on, it's helpful if you come in here and you say, well, I see a minus 6. The opposite of subtract 6 is add 6. And if I do it on the left side, I have to do it on the right side. And that's where the 8 comes from, because I have a positive 2 plus 6 equals a positive 8. I now have figured out that they added 6 to both sides. So what we've done here with this plus 6, we have to put into that blank for B. So what happened from A to B? We added 6. And because I added on both sides, this is the addition property of equality. Now you can abbreviate. I knew I was going to run out of space because my handwriting's a little bit large. If you want to use POE, that's fine. But you should have that property of equality. We didn't just add. Adding would mean that I'm adding on the left side or I'm adding on the right side, one or the other. We did both. So that is a property of equality. All right, so then now, again, get rid of a little bit of this. Now our job is to figure out from B to C what happened, what changed. So I don't have, look here, I have my 5x. There's not a 5x down here. There's a 2x. That's different. I still have my 8. That stayed the same. So that change wasn't there. So what happened was with my x's, something changed there. So let's figure out, I have a positive 3x. Wouldn't I have to subtract 3x? Because 3x minus 3x is 0. Subtract 3x. And then 5x minus 3x is 2x. So I do get that 2x when I do that. All right, so this piece that I wrote with that minus 3x, and remember the stuff in blue that I have here, with the exception of the addition property of equality, is kind of like a help, not necessary. But I subtracted 3x on both sides, so you can go back and look at your notes, but that is the subtraction property of equality. So it pretty much lines up with, well, what operation did you use to solve, to move that piece so that you could solve the equation? All right, I'm going to do a little bit more erasing, just kind of clean it up so that you can see the next piece. All right, so for the last blank, we have to figure out from C to D what happened. So that's the question. What happened? What changed? So I went from a 2x to an x. I went from an 8 to a 4. And so remember that we're trying to isolate that variable. So to get that variable by itself, I know it's 2 times x. I'm going to divide both sides by 2. And 8 divided by 2 is 4. So that would mean that in this last blank, I would have to write that I'm dividing by 2. That would be the division property of equality. So really what you're doing is for each step, each decision made, you are stating why you're allowed to do that. So let me go back and just kind of walk you through this problem. Okay? Let's clean this up a little bit more. Okay. So from here to here, I moved that 6. I added 6. Why am I allowed to add 6? Because the addition property of equality says I'm allowed to add the same number to both sides. All right, from B to C, I subtracted 3x. Why am I allowed to do that? The subtraction property of equality allows me to subtract the same thing on both sides of the equal sign. From C to D, I got there by dividing both sides by 2. Why am I allowed to do that? Well, the division property of equality says I'm allowed to divide both sides by the same thing. Okay, so for each blank, each step that you do, each operation that you make, you have something to write. And then you always start with given, always. So if you are writing out the problem, which we'll do in a little bit, writing out the problem, then you write given. And then for each step that you make a decision. And then what I usually do is I just kind of bump over right next to it and write, this is why I made that decision. Now, not everything's a property of equality. Remember that last little bit on last slide where it was like the distributive property, not a property of equality, because that's not happening on both sides. And even if it does happen on both sides, the same thing isn't happening on both sides of the equal sign. The simplify and the combine like terms, those are not properties of equality. So I won't write property of equality for everything. All right, let's look at 2. So we start with given. We're always going to start with given because that's the problem that was given to us. And we have to determine from A to B what step was made. So it looks like I have 5 in a set of parentheses. And then when I come down here, my 5 is now with an x. And I don't have a 3, I have a 15. Well, 5 times 3. So it looks like I did one of these. 5 times x is 5x. 5 times 3 is 15. So that is the distributive property. I'm going to write in red this time. Now, I know that the word distributive property is hard to spell. It'll be okay. Do your best. But you want to spell out enough of it so that you kind of get used to it because you may have to type it. Okay? All right. Let me clean this up a little bit. From B to C, a change was made. I have my 5x. I don't have a 15 anymore, and my negative 10 becomes a negative 25. So something happened with that constant. How do you move a plus 15? You subtract 15 on both sides. So remember our 0 pair? And then negative 10 minus 15 is negative 25. Some of you are having trouble with your addition and subtraction, so watch out for that. So that works, right? We got negative 25. So this piece is right. I subtracted on both sides, so that means that this is the subtraction property of equality. Now, if you want to abbreviate, go for it. But just know POE stands for property of equality. All right, to go from C to D. Oop, I lost my notes up here. Okay, to go from C to D, something happened, something changed. I went from a 5x to an x and a negative 25 to a negative 5. So that would probably mean that I had divided both sides by 5. So if I divide both sides by 5, I'm looking at the division property of equality. Okay, so your job is to fill in the blanks with the appropriate steps that have occurred. Come on. Oh, there we go. Now it's you try. So you're going to pause the video, try to figure this out. All right, you are back. So let's look at 3. We're going to look at A to B. Now we already know A is given. That is always going to occur. You always write that anytime you write the problem down. You don't have to worry about filling that blank in right now. But we've got to figure out what happened. So I see negative 11 is still around. And I see 2x is still around. So there is a change on the left and a change on the right. So let's explore that. So here we have 4x minus x. 4x minus x is 3x. Ooh, so it's like they subtracted and they put those together. Interesting. Over here, let me change other colors. Let's do green. Here they had 2 and negative 20. 2 minus 20 is negative 18. So they did something on both sides, right? They really kind of subtracted, my voice kind of cracked there. They really kind of subtracted the same thing on both sides. Well, not the same thing. Whoa, whoa, whoa. Fix that, Phoebus. They did not subtract the same thing on both sides. They subtracted x's on the left, and they subtracted constants on the right. So they did not subtract the same thing on both sides. So this is not a property of equality. These are 2 different things. And this kind of goes back to, remember how I told you some of the wording. What if they subtracted on one side and added on the other, right? Not a property of equality, but still something that they could do. So this is where I want you to write combine like terms. Combine like terms. Now, if you want to abbreviate so that you don't have to write it out, you could abbreviate it CLT, combine like terms. I accept that abbreviation. That is something that I do know. Okay, so combine like terms is what I want you to put there. Even though they subtracted on both sides, not the subtraction property of equality, I'm going to encourage you not to use the word simplify and not to use the word subtract. Okay, they combine like terms. 4x minus x is 3x, they combine like terms. 2 minus 20 is negative 18, they combine like terms. All right, let's look from B to C. Something happened. So I still see my negative 18 here, and I still see my negative 11 here. So what's changed is this x, and so how am I going to move a 2x, because I went on the left, so I'm going to subtract 2x on both sides. 3x minus 2x is, there's a 1 there, 1x or just x. I really want you to kind of start moving to the idea that you can write 1x as just x. It's just kind of easier. It's less to write. All right, so I subtracted the same thing on both sides. So that I can write as the subtraction property of equality. And there is a difference between what I did here and what I did in the step above. So if you're having trouble telling the difference between those two, you need to give me an email going, right? You're like, hey, I'm still having trouble with this, and I'll do my best to help out. All right, we're going to go from C to D. Something happened. Let's try to figure out. X is still there. X didn't change. Something happened over here with the constants. Let's see if we can. Something happened with the constants going from C to D. There's our X. So we moved that negative 11 over. How you move opposite of minus 11 is add 11. So negative 18 plus 11 is negative 7. So that works out. So I added the same thing to both sides. That's the addition property of equality. Okay? Now, if you had trouble doing that by yourself, that's okay. You're learning this and you're going to get better and better at it. Okay? And I can help you out. All you got to do is say something. but we're providing reasons, and you can go back and you can look at your notes and you can use those to help you figure out those reasons. But really, you're looking to see what has changed and what in the notes allows you to change that. All right, now this one's a little bit harder. If you feel like you are up for the challenge, you can go ahead and do that by yourself. You can pause the video and see if you can figure it out. If not, I want you to still pause the video. I want you to write this down, and then in just a second, I'll go over it. All right, so of course we have our given. That's always going to happen first. So if I look, notice here that this piece and this piece matches here and here. Okay, so they match. The only difference is that we've multiplied both sides by 4. Now, some of you are like, why in the world would they do that? Well, if you look at this line, notice that we went from having several fractions to now we don't have any fractions. So they multiplied to remove the fractions. And we're multiplying, ooh, the air conditioning kicked on. We're multiplying by the same value, right? We're multiplying both sides by 4. So this is the multiplication property of equality. All right, to go from B to C, what happened? Well, they had parentheses. There's 4's outside. Here and here, they did something. Here and here, they did something. Yes, it happened to be multiplied by the same number, but they're not the exact same set of parentheses, so it's not really a property of equality, but it is a property. It is called the distributive property. So notice I'm not writing POE. It's not a property of equality. Yes, it happened on both sides. It just happened because we had multiplied both sides by 4. It's not a property of equality, though. All right, let's look from C to D. Now, some things are still the same. I have a 2. I have that minus 2. So those pieces are the same. Looks like we moved the 5x to join the 8x. And so how do you move a 5x? It's the opposite of a positive 5x, so that would be a negative 5x. So remember, negatives and minus kind of go together. So we're going to subtract 5x on both sides. So if I subtract 5x on both sides, that is the subtraction property of equality. All right. Let's see if we can figure out what happened next. We're going from D to E. Do you see how I keep drawing this arrow? And I'm writing on this stuff. I highly recommend, especially at the beginning, that you're doing something like that. I'm erasing just because I want not to kind of keep working with the other stuff around it. But if you can kind of keep straight what you've already used and what you're looking at and all of that, you don't have to erase. I have 3x. So the 3x didn't change. It was this negative 2, this minus 2 moved over. The opposite of minus 2 is add 2 plus 2. So 2 plus 2 is 4. So it looks like I added 2 to both sides. And the addition property of equality says I'm allowed to add the same thing to both sides. All right. Okay, we're going from here to here. E to F. So looks like my x is by itself. Looks like I divided both sides by 3. So that's the division property of equality. All right, and then my last move, and again, this goes back to those ones that we wrote in our notes, and I had you star a couple. This was one that I had you star. Remember that you are allowed to flip what's on the on each side of the equal sign as long as it's equal to each other. So 4/3 equals x is the same as x equals 4/3 because there is a symmetric property of equality. Okay, because you're going across the equal sign, right? They're flipping across the equal sign. It's a property of equality. Okay, so these are called two-column proofs. You have a left column where all the math is being done, and a right column where all your justification is happening. Next, what we're about to do is we're about to make our own, where all you're given is given. You're just given this guy, for instance. And what you have to do is you have to build all of this. Okay? Now, I'm going to give you some guidelines. I'm going to walk you through several of these. And I'm going to kind of show exactly how you're going to do this. Not exactly, but I'm going to kind of give you an idea of how you're going to put this into Canvas. Okay? So, let's look at our first one. Maybe. Come on. There we go. So here is our own two-column algebraic proof. Now, we're going to use this in algebra. It's going to pop up from time to time, especially once we kind of move on from this unit. It's going to pop up and it's going to say include justifications. And so that's your reasons why. Some of you are going to forget what justification means. So justification is just your reason why. If you are writing this yourself, you definitely want to make the table. If you are putting this into Canvas, and you would be putting this into Canvas in the essay portion, what you would do is you would write your statement, so like 1/2 parentheses a plus x, the problem, and then you would like give me some spaces and kind of like make a gap, and then just in line with that, you would type given. Okay, so as long as they're in the same line, it should be fine. And we will probably working soon on math type stuff, maybe making a video for you to see how to do it. Everybody should be able to access that. I know that we're having some problems taking pictures with the Chromebook. So I've had some of you take pictures with your phone, but everybody will be able to access it. Now, you might not be able to find what you want. That's a different story, but you will be able to access the math type feature in the essay portion, and I'll show you what that looks like. But really, you're just going to be putting space, 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 and then it's up to you how many spaces you use. I'm not really certain. I don't think I care. So if you want to make it look really good, great. But what you're going to do is you're going to have another equation piece, and then space, 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 and then your reason. Okay? So that's what I'm looking for when you go to type this into Canvas. Now, you're going to make different decisions than I may make. Sometimes you could, I don't know, combine like terms later than I would. That's okay, as long as when you go to do it, you're justifying that at the right time. So when you do it, make sure you're saying that you're doing it. The other thing, and I want to write this out because I'm going to get some people that are like, oh, you can only really do one step at a time. Okay? Don't be like, hey, in this step, I use the addition property of equality and the subtraction property of equality. No, you do them in two separate steps. Now, a couple problems back, they work combining like terms on the left and the right. They were doing two steps, but there was one reason, because it was the same reason. So you can combine steps. It is possible. However, I will have people do a whole bunch of stuff and then say, I did this and this and this and this. And that's not what I want to see. I want to see, I did a move. Here's the reason why. I did another move. Here's the reason why. So I really want you to focus. I don't want you speeding through these. I want you to make sure that you know each one. But you can do things in a slightly different order. You may choose to do, a different way. So I'm going to, in this case, use the distributive property first. So I'm going to have 1/2 a plus 1/2 times 6 is 3, plus 2a equals 8. And then I'm going to come over here, and sometimes an arrow is very helpful to keep everything straight. If you've got lined paper, that should be pretty easy. But if you're working with something that doesn't have lines like I am, an arrow kind of helps keep it straight. All right, so I've got 1/2 a plus 2a, and I want to rewrite 2 with the denominator 2. So I'm going to write this as 4 over 2a, because 4 divided by 2 is 2. And then what I want to do, oh, I'm moving on. I want to get that reason in there. So what did I do from here to here before I started picking up the blue pen? I did the distributive property. I got ahead of myself. I was excited. It was fraction time. Yes, I am weird. You will come to love me, I hope. All right, so now I changed my fraction to a 4 over 2a so that I can combine it with a 1/2 a and 1/2 a plus 4 over 2a. 1 plus 4 is 5, so this is 5 over 2a plus 3 equals 8. Now, what did I do? I combined my a's, right? I added them together. But if you look back into your notes, if you're going to do that, I really want you to write combined like terms. Or if you are one of those people that like to abbreviate, CLT works for me. Hey, that rhymes. All right, now, what is my next move? Well, my next move is to start isolating that variable. So I want to move that plus 3. I want to subtract 3. Now, technically, this minus 3 that I'm writing right here, not necessary. So you don't have to write it. Some people really like to write it. 8 minus 3 is 5. But what did I just use? Subtraction. Because I subtracted 3 on both sides, right? Property of equality. Hey, I can move that. Now it's not in the way anymore. Woo! Okay. I've got one more move to make. Technically, you could do it in 2, but I want you to do it in 1. And it's not dividing by a fraction. If you were like, she's going to divide by 5 over 2, wrong, try again. We don't divide by fractions in this class. We multiply by the reciprocal. So we're going to multiply both sides by a value, and we're going to multiply by the reciprocal, 2/5. Okay, don't want to divide by a fraction. Look at this. 5 divided by 5 over 2. Is that any better? That just makes people want to cry. We don't want to cry. We don't want to cry. We like math, most of us. I do. I like math. All right, this ends up being 10 over 10. Not a problem there. All right, and we are going to have A equals, and then this is, ooh, I can do that little simplified trick. So that's 1 over 1. So really it's A equals 2. All right, now what did I do? Well, I multiplied here. Let's see. I multiplied here and here. That's the same number, right? I multiplied both sides by the same number. So that's the multiplication property of equality. Now, if you go to write this down and you're writing division property of equality and you had a fraction, know that you hurt my feelings and made me cry. So sad, so sad. All right, that was our first 2 column proof. I'm so proud of you. We did. We've done it. I wish I could speak English. All right, yay! Look at this one. Oh my, we got some fractions. So exciting. So you're going to write this down. And what I want to do is I want to think about what my process is. So I could work with the fractions, or I could work on getting rid of the fractions. What do you think? Should we work with the fractions, or should we eliminate the fractions? Now, I would really be asking you this question in class, and most of you would be like, get rid of the fractions, I'm pretty sure. So I think I'm going to go that route, but you could do it with the fractions. I'm not saying that you can't. I'm just saying that you just have to work with them a little bit longer. Does that make sense? So we're going to start. Here is our given statement. So we're going to start by saying, hey, given. Now you may be like, Miss Phoebus, why are we doing this? Well, we're solving equations. We're practicing the reasons why we're able to solve equations. And guess what? When you go to geometry, and some of you have Mr. Harris for advanced geometry next semester, you're going to be doing these but with geometry. And if you get used to these, when you get to geometry, they'll be a piece of cake. Okay? So I'm going to work on getting rid of these fractions. And what I want to do is I want to multiply both sides. So I'm going to put both sides in parentheses. And I want to multiply by the largest denominator, probably something that will work out with the other denominators. Notice I have a 3 in a denominator, a 3 in a denominator, and then a 6. So if I just multiply by 3, it's the smallest denominator. I'm still going to have a fraction around because it'll be 3/6, which would still be a half. Wouldn't be too bad, but I'd really like to clear out all the fractions. So what I'm going to do is 3 is a multiple of 6. So when I multiply both sides by 6, I am going to be able to not have fractions anymore. Okay? So let's see what happens after well, actually, let's do this because I don't want to combine too many steps, right? Remember that? Don't combine too many steps. So even though I put my parentheses here, I'm going to do 6 2/3 x minus 7 equals 6 1/3 minus 1/6 x. And what did I do? I did the multiplication because I'm multiplying both sides by 6, property of equality. All right. Now we'll do the multiply. Now this is going to actually be the distributive property because remember there's two things that's happening there. And there's two things happening here. So it is going to be the distributive property. So I really want to think of this 6 as 6 over 1. And 6 times 2, I'm multiplying 6 and 2. 6 times 2 is 12. 12 divided by 3 is 4. So that's a 4x. No fraction there. Woohoo! Loving that. All right, 6 times negative 7 is negative 42. No fraction there, but we didn't have one. All right, 6 times 1, we're on the other side of the equal sign. 6 times 1 is 6 over 3. 6 divided by 3 is 2. No fraction there. Feeling good about this. All right, and then the last piece, 6 times 1 is 6, and that's negative 6, divided by 6. 6 divided by 6 is 1, but I've got that negative there because it's a positive 6 divided by a negative, or multiplied times a negative 1/6, so it's going to be a minus x. So I've got the distributive property. Not a property of equality, though. I'll put a period at the end. All right. Now, here is where you could have some variation, and I didn't really talk about variation, but let's say for some reason you didn't want to move your x's together. You're like, oh, that 42, I've got to take care of it. You could do that as long as you use and write the correct property of equality in this case. Okay, so order I'm not going to be fussy about, but I am going to want you to, if you did something different, just make sure that that justification is in line with what you did. Okay, so just make sure you're following the rules. I'm actually going to move the x's because that's just me. I'm a stickler for rules. All right, so that's 5x minus 42, not 24, equals 2. So that's that don't call me after midnight kind of rule. And we added x to both sides, so that's the addition property of equality. All right, I'm going to add 42 to both sides. Now, some people would say, well, Miss Phoebus, doing addition property of equality twice. Why can't I just do both at the same time? Don't do that. You do too much for your little brain to handle. Too much for my brain to handle. Won't be good. Okay, I want you each time you do something to be doing it and then assigning that property of equality. Better for you. I'm going to switch colors because I'm getting down in the black. I'm going to be dividing by 5. All right, so x equals, now don't you do it. Don't you go reaching for that calculator. Don't you be trying to change it into a mixed number. You can't do anything with 44 divided by 5. They're not divisible by the same thing. Look here, 44 fifths. Now, is it wrong to put 8 and 4 fifths? No. Is it wrong to put 8.8? No. But why? I don't understand. It's an extra step. Get your brain going, and we divided by both sides, so we're going to write division, property of equality. I want your brain to be in improper fraction world, and I guarantee you, if you join me in this wonderful land of improper fractions, you're going to be like, I'm done already? Yeah. They trained you so well in middle school to change them to mixed numbers and to change them to decimals, whereas I'm like, yay, improper fractions. All right, let's see if we can get a couple more. This video shouldn't be as long, but it's pretty heavy duty. All right, it's a you try. I want you to try to see, at the very least, solve the problem. That's the very least you need to do, solve the problem. If you can add the justification, I like to add it as I go. But pause the video, see what you can do. All right, you're back. So you should have written the problem. And then the very first step is always, anybody know? Given. I feel like Dora, you know Dora the Explorer, and she's like, where do we go? And then she's like, that's right, to the hill, or whatever, or to the big tree. That's what I feel like. I'm talking to myself. All right. All right. So we have our given problem, and so then now we have to figure out what our next step is. And so if we think about that, don't call me after midnight. Don't call me after midnight. The D stands for the distributive property. Do I have any distributive property? Oh, I do. I'm going to distribute this 5 to both pieces inside the parentheses. So 5 times 2x is 10x. 5 times 8 is 40. Plus 3x equals 1. And I just distributed, so I'm just going to come right over here and write distributive property. Not a property of equality. If you wrote of equality, mark it out. And right, don't do that. All right, C, so I did the distributive property. C is combine like terms. I'm going to do that. Combine like terms. Do I have any like terms? Look, I've got a 10x and a 3x. 10x plus 3x is 13x. Do you notice that don't call me after midnight is pretty much our justifications? Combine like terms. All right. Do we need to move the variable? I only see one variable. I only see that 13x. So there isn't another variable to worry about. So I'm going to not do that one. We're not doing move the variable. How about add, subtract? Let's look at moving our constant. All right, I see a positive 40. I want to move it away from x. I'm going to do the opposite of add. I'm going to subtract 40. So I'm going to get 13x equals 1 minus 40 is negative 39. So what did I do to get this? 13x equals negative 39. I subtracted, so that's a subtraction, and I subtracted on the same side. Property of equality. All right, I think I got one more. Remember that don't call me after midnight is the last one is multiply, divide. So I've got 13 times x, not a fraction. So I'm going to end up dividing both sides by 13. So x equals -3. So I use the division property of equality. All right, now this is going to be something that you're going to need to practice. This is something that I expect you to be looking back at your notes. Okay, go back and look at example problems that you did. Try to get it into your head, kind of the flow of everything. If you're having trouble, you need to be emailing me, okay? But you're only going to be doing about 10 problems in the homework. So don't go overboard on homework. You're just going to be doing a little bit at a time. I'm pretty sure this is the last slide. Let's see. Yep, that's the last slide. So I'll see you in the next video. Bye.